Welcome to the SQL Challenge, speeding up the popular names query. I'm Kendra Little from SQLWorkbooks.com. The query that we're tuning today ranks baby names in popularity for a given year. We specify a given year and it gives us the top 10 names for that year, and then it also says what's the rank 10 years later. It uses an inner join for that. In addition, it uses outer joins to look at the rank 10 years prior, 20 years prior, and 20 years later if those rows exist. Here is an example of query results when we pass in the year 1991. You can see that Michael is ranked number 1, and he's held that rank for a while. He was number 1 20 years ago as well as 10 years ago, but in 1992, he drops down to rank number 2, and 20 years after this, he is down at rank number 10, but he's still in the top 10 20 years later. If we look at other names like Ashley, she may be ranked number 3 in 1991, but she's come a long way because 20 years before she was ranked 439, but Ashley, her popularity as a name does go down, and she doesn't stay in the top 10 for too long. So this is our example data set for 1991, and our challenge is to tune the popular names query that returns this data set and to rewrite only the T-SQL. Our challenge isn't to touch indexes. We only want to be changing the T-SQL, and we want to make it so the query uses less than 500 logical reads when run for the year 1991, and we do want it to return the same result. As we walk through sample solutions for this, you're going to notice that there's different types of tuning we're going to do here. We're going to first look for quick fixes. Is there a way that we can just quickly make this work, even if it has some downsides? And we'll talk about what those downsides are. We'll then look for a more scalable, longer-term solution. Can we get the query under 500 reads without using those quick fixes? And we'll step through a real-world query tuning process to get to that more scalable fix. I've already downloaded the sample database for this. This is the exact version of the sample database that you'll be seeing in this script. We do get new baby names every year, and I am about to update this with names from 2017 that have just been released. But in this current version of the database, in release 1.2, we only have names through 2016. I've already run this code here that restores the database and makes sure that the database compatibility level is set to 140. All of that has already completed successfully. And so before we start tuning, we're going to just take a quick tour through the popular names query. The way the query is written, it has a local variable at the top called year to rank, and then we've got a common table expression named rank by year at the top. The common table expression rank by year has a query in it that pulls all the rows from ag.firstname by year, and it performs a rank on them. It looks at the row and then it says, okay, in the context of this table, I'm going to group or partition the data by report year. And for each report year, I am going to order the data by name count descending. I'm going to do this for a rank function. So I am ranking for each report year ordered by names count descending. So the name counts who are the highest, the babies, the names that had the most babies, use that name, they will be at the top. So rank by year, our common table expression, is referenced in our query multiple times. Our from here, we are selecting from rank by year, aliasing it as start year. For start year, we are returning columns from that. We're returning the gender from it. We're returning the rank from that start year. And then also we have some predicates on it down at the bottom of the query. We are looking at rows where the start year dot report year is equal to year to rank. We are specifying 1991 as the value for the local variable year to rank. And further, we're saying we want the names who in start year, their rank was in the top 10. Now we are joining to other versions of that CTE, we're saying join rank by year as 10 years later as well. And for this one, who's 10 years later, start year dot report year plus 10 is what we want that to be. So we want to look at the table and say, okay, we want to go 10 years ahead and look at the rank there. And for 10 years later, that is what we are returning for 10 years later, the rank that year, and then we're aliasing that column as rank 10 years later. Let's go ahead and give our query a run. We haven't done any tuning yet. We're just looking at the problem query here, and we're using the set statistics IO statement at the top of the session to say, when you run the query, after you complete this is set statistics IO. I've also said turn on statistics time as well. This tells it, SQL Server, please print to the messages tab. This is the statistics IO portion. And here it tells us how many logical reads did. So before we're trying to get this under 500 logical reads. Just against our reads for the first name by year table alone, we're at 26,000. So we have a ways to go to get this down to 500 logical reads or less. Looking at our data results, there is Michael. He is number 1, and here are our results. So our next step is going to be stepping through our query and figuring out how can we get this below 500 logical reads.